Let's go through the code 2472. Maximum number of non-overlapping palindrome substrings. It gives us a string S. It asks how many non-overlapping substrings and which are palindrome. And these substrings, they need to be length at least k. And ask what's the maximum number. So intuitively, what we think about this question is that we want get this palindrome and as left as we can, right? And also we count, for example, um we count the first palindrome, which is greater or equal to k. Then we have index I, right? Then from this index I, trying to count to the next one, right? So we can do a pre-processing to use a DP, which is a multiple by n array, right? Which is an DPIJ represent from index I to j whether it is a palindrome or not, right? So we can write this approach first. So what we do is that we're going to have char array equals S2 char array, right? And int n equals array dot length. So for int I equals to 0, I smaller than n, I plus plus. Initially, we know every single character substring, it is an palindrome, right? So we'll say dpi I equals true. And we'll say if I plus 1 is smaller than n, and array I equals array I minus 1, right? So we're going to have dp I plus 1 equals 2, right? So this is for the since that for the length 1, length 2, we already have the initial state that is whether they are true or not. Then we are going to for int length equals to 3, length is smaller than equal to n, right? Length plus plus. Then what we do is for int I equal to 0, I plus length smaller equal to n, I plus plus. So int j equals I plus length minus 1, right? So the thing is that we'll say um if we're trying to see whether this I to j whether they are palindrome or not. That means if they need these two characters, they are the same, and also this is palindrome, right? I plus 1, j minus 1 is a palindrome. So what we do is that if array r equals array j and bp I plus 1 j minus 1, then we're going to have dp I j equal to true, right? Then after this, we just greedily to count how many palindromes. So we have int result equals to 0, right? And we're going to have pre-index equals minus 1. That means if we find a palindrome, then we'll set this pre-index as a J index or a right index we find, right? Because there need to be no overlapping. And so that when we, for example, our J or right pointer keep on moving, our left pointer should not be left than pre-index. What we do is that for int j equals k minus 1, j smaller than n, j plus plus. Then we are going to for int I equals j minus. The thing is that we should not j minus k, should j minus k minus 1, right? Because both I and j, they are inclusive. And the length between I and j, that is j minus I plus 1, j greater than pre-index j minus minus. So let's say if dpij is from ij inclusive, it is a palindrome, what we do is that result should plus plus, right? Then we'll have a pre-index equals j. And actually, our j can move. We don't need to move. We can move just directly by k minus 1, right? And just k minus 1 because the j after uh, jumping this for loop, j will move again, right? So we'll move j minus 1 and break. In the end, just return result. Doing like this, the time complexity will be O n O n multiplied by n, right? Um, because there are for loop, right? This is length is n and I is n. So this n square time complexity space, we have a DP array, right? That is also a n square space complexity. So let's look at this is true. I plus 1 is true. For length equals I length small equal to I plus if array these two charts are equal and the dp I plus 1 j minus 1, then this is true. Result greater than preindex j minus minus if dp I j minus 1 break. So let's look at I plus 1. This is length somewhere equal to n j equals this is I because we are moving j is on the right. Doing like this, the time and the space complexity are both O n squared. But actually, for this question, we can do better. Assume for this string, right? We already calculate to this index, right? How many, for example, we have a count 1, right? Then we'll count for this kind of from this index to the next. Okay. So if brute force doing like this, what we do is that we are going to have, for example, this is I, right? And to I minus k plus k minus 1, trying to check whether this is an pendulum or not, right? And if not, what we do is that we are trying to check I plus k, right? And if not again, what we do is that we are going to check I plus k plus 1, right? But the thing is that if we check the string from I to I plus k plus 1, if I plus k plus 1, it is to I, it is a polynomial in this real part. We'll say because it is polynomial, one thing is that we know these two characters are the same, right? That means from I plus 1 to I plus k, it is also a polynomial. So do we need to uh, iterate to check from I to I plus k plus 1 is a polynomial or not? Actually, we don't. because I plus one to I plus k, it is a polynomial, it is greater or equal to k. And and um, and also the length is smaller, and the right end index is I plus k is better than I plus k plus one, right? So if why we have smaller interval and a beta approach, we don't need to to judge in a greater range, right? Why we should still count I to I plus k plus one. We just need to for every I, we just need to count I to I plus k minus one and I to I plus k, these two cases, right? So if we know this, we could just greatly count. So let's write code for this, right? Um, array equals square array. Then what we do is that int a equals array dot length and the result equals to zero, right? What we do for int I equal to zero, I plus k smaller equal to k n, right? I plus plus. Then what we do is that if is palindrome array I plus k minus one, then we just have result should increase by one, right? And I should plus equal to k minus one and continue. And we'll also check another case that is from I to I plus k. Then we'll have result plus and I plus equal to k and continue. Then return result. We need a have function private boolean is palindrome. So what we do is yi smaller than j, right? If array I doesn't equal to array j, just return false. We need this if I plus k is smaller than n. So doing like this, the time complexity will be, you see, we just iterate every I from I, this is n, right? And for every I move, we just check two cases, I to I plus k minus one and I to I plus k, whether it is dependent or not. This is O, this k, right? So it will be O and k time complexity. And we don't have an actual space. Python code will be very similar. Um, let's write a Python code. We have int n and result and I equals length s and the result initially as zero, I equals zero, y I plus k small equal to n. I do this because the thing that we have if, then I should plus equal to k minus one, right? Then we have an I plus equal to one, right? Doing like this. Because in the if cases, use a for loop Python is a bit different. So let's say if it's palindrome s, we don't need s, I plus k minus one. Then we'll have result to the plus equal to one, right? And what we do is that I should plus equal to k. and continue. Because we continue, right? So this is not I plus k plus one, should plus equal to k. Um, and what we do is that if is palindrome I plus k, then result should plus equal to one, and I should plus equal to k plus one right now, and continue. And let's define is palin palindrome I int j int return boolean. So this is that while I smaller than j, if si equal to sj, then just return false. Then we should have I plus equal to one, j minus equal to one, and in the end return true. Here we should return result. Here, and I also have I plus k just smaller than n, and